Hello YouTube, this is Alexander again. Today is a kind of discovering day. I have here on the bench two very nice multimeters. I chose those multimeters because actually they are a very nice brand which is RICHMETERS. This is not an Aneng multimeter like we usually do on this channel, but I'm not special sponsor for. I'm not special fan of Aneng, even if they give very nice tools for the price. I'm just interested by the possibility to have a very nice tool simply according to the price we can find on internet, etc., coming from the China market. So here we have the RICHMETERS RM219 and the RICHMETERS RM303 meters, and this one is rated on the board mainly for true RMS, and this one is rated on the board mainly for 600 volt Gate 3 and 1000 volt Gate 2. So the RICHMETERS RM219 true RMS is provided with a very serious probe. Actually, as you can see here, there are very serious probe like you can find on any 8 brand multimeters. They are a little bit cheap, but acceptable from my sense, and the made of this probe is actually very nice, I think, for the price, and we don't have to complain about this stuff. And also you have on the pocket this little probe which is a chip K sensor, and it can be very useful actually to make some measurement with this if you don't have any tool to replace and if you don't need a special accuracy. This tool can be very interesting for you to give you a very nice measurement of temperature if you need it actually. So you have the meter itself and also a little manual, user manual, and you can find some information on it to learn eventually if you need to learn to use a multimeter. I guess for many of you who are looking this video, I think you don't need this kind of manual, but this is actually very current to find this kind of stuff. So you have here the RM219, which is branded like true RMS, and actually this is a very nice multimeter. I'm gonna show you this further. And here you have the RICHMETERS RM303 multimeters, which is actually not exactly the same, but very similar actually. It has a different it has actually a different size and a different shape also. They are really different because this one is heavier, this one is more little, and also they are not exactly the same in terms of features they can provide on the board here. So also, the RICHMETERS RM303 is provided with those tiny cables, tiny probes, which are a little compared to the other probe coming from the RM219. And according to the size of the multimeter, it can be easy to understand why they use a little cord like this. It looks like mini multimeters, but of course it's actually a big multimeter. If you need to compare the size of the Aneng 8002, you can see it's a little compared to the RM303, which is bigger than this one, but they share exactly the same design and the same size. Not the same features, but actually the same size, not the same size, the same features actually. So this one was the first version of very cheap multimeters according the accuracy and the revolution of the cheap multimeters with high accuracy which can make competition with other familiar brand. And so on those multimeters you can find very similar boards, and there is a main difference. The main difference between this one and this one is that you don't have a temperature measurement on this one, whereas on this one you will have a temperature measurement according the thermocouple you can connect on those leads. So both multimeters have 19,999 points of resolution on their screen. And if you look, let's peel off this screen, and if you look here, you can have, it's not visible, but you can see here the one digit coming from to make the 19,999 point. Also on this one it's exactly the same thing. You can see the one digit appears quickly here, and what you can understand is that this kind of build share exactly the same components for to make those multimeters, because they are the cheapest way to make 8 degrees multimeters and 8 resolution multimeters, because those screens are exactly the same, even if the operators is not exactly the same. So here you will have on this one, on the RM219 true MMS, you will have here separately from this one, you will have here the alternative voltage, and here above this one you will have the continuous DC current, DC voltage, whereas this one share the alternative voltage and the DC voltage on the same caliber. To read the DC voltage on this one, you need to turn the rotary button to make a DC voltage reading. On this one, you just have to push the button to select between the AC and the DC. On the millivolt readings, which are nearly the same on each devices, you will have here the millivolts readings, and exactly the same on this one. But this one is able to give you temperature readings according the select button here. You can read the AC millivolts, and if you push the button again, you will have the current temperature according the sensor on the device. And if you use this probe and connect this probe, you will have automatically switching on the probe, external probe on the multimeter, and you can see if you put the probe on your hand, you can see a temperature raising on the screen. So on this one you will not have the temperature readings, but you only have millivolts readings. Also, if you have special requests, you can read the temperature according to the millivolt you can read, because a thermocouple is able to provide a millivolt voltage to your operators, which can give you an idea about the temperature of the thermocouple. So if you can see, if you can see, for the instance, this is a lighter. You can see the millivolt reading. If I heat up, you can see the millivolts is rising a lot because of the heating very fast of this heater. So, okay, so you have also on the same way you have an ohm readings on the same way, and you have exactly the beep, the diode, and the capacitors reading. So this is exactly the same on both multimeters. So here exactly on the same way, and in the same way you will have the hertz and the frequency and the duty cycle readings. So the duty cycle is special readings of alternative current, which gives you the percentage of the DC, of the AC voltage, according the power you can provide from an AC voltage. Also, you can make some measurement about the RMS voltage with this kind of duty cycle. Here it gives you an idea about the power of a signal with the duty cycle. So here you, on this one, you have the amperage readings, which is here able to read the alternative and DC current from selecting the button and choose between the AC and the DC current. On this one, you can have exactly the same thing, and you can choose between the AC and the DC between just with pushing the select button. And of course, all the select button are here on the right side, whereas in this one it's on the left side. So you have also milliamps. Milliamps are readings exactly like this one, because you can choose the AC milliamp or the DC milliamp, whereas exactly on this one you can see you can select between DC milliamp and AC milliamp by switching the button. Also on both multimeters you can have the microamp readings, which is a very nice thing to make electronic, because electronic sometimes you can have the need of reading microamps. Also you will have the NCV, and the NCV is able to read, it's able to give you the proof of the presence of alternative voltage electrostatic field on the multimeter. You can see when I put my hand here, I give some electrostatic field to the sensor, and it's able to react to the electric field. So here you can see the voltage readings compared to bench multimeters and another bench multimeters, and this one is actually non-brand Matrix MX 945 Matrix, and it's a very nice brand, and you can count on this kind of stuff to see if the accuracy is correct. So on the RICHMETERS RM219 to RMS, you can see a very near value about the voltage reading coming from this little device, which is a voltage reference actually. And on the RM303 you can see a very near readings as this one, which is according to the reads on this very nice matrix. The accuracy is very impressive, and you will have nearly on this 80,000 count, you can see this reading, which is very near from these readings coming from those very cheap multimeters. So about the 5-volt readings, you can see about the dot here, you can have 2,0, and you will find not exactly a perfect value, but according the accuracy on those one, you can see for the price, it can give you a very nice value for the money. And according to the precision of this little 5-volt generator, you can think that those multimeters are very nicely made and give a very nice result. Mostly when you can see this matrix giving 5-volt, exactly 5-volt, despite the hold of the unit, and this one is like brand new multimeters. This is not the most expensive. It can do the job for the money on the bench, and we use it to compare those very cheap multimeters. So for the 7.5 V, you can see the little offset you can see on the multimeters. They are not perfectly linear, whereas this one is perfectly showing the good value coming from this voltage reference. Also, this Vichy 8145 dual display multimeter gives you a very nice display according the value coming from this little device. And okay, this is not perfect, but it's enough accurate, I think, for a lot of people who are looking for a very nice multimeters for the price. So if you go for the 10-volt readings, here you can see perfect accuracy according if you are looking the accuracy about the first digit after the dot or the second digit after the dot. You can see here it has the same value than this one, but this one has a digit more, and those one are quite nice actually. This one is more perfect than this one because the offset is little. This one is about 10, this one is about 6, and you have a little difference between them, but nothing significant at my sense. And I think those multimeters make very nicely the job for the price. Okay, let's make some measurements now with a millivolt voltage. This is a millivolt calibrator, and it's able to provide a millivoltage on these multimeters. As you can see, the accuracy is very nice despite the very low voltage, and you can see on the both multimeters then the value is pretty the same, and I'll let you see the accuracy of this device according to the Victor millivolt calibrator. And that proved that those multimeters are very impressive. Now let's see RTD readings. RTD is the resistive impedance of a temperature probe, and it's able to provide a resistive output, but in this case you cannot connect two multimeters in parallel to read the same RTD. You need to measure for each multimeter separately for to have a nice correct value. You can see here on the first multimeter that it's the display is very accurate, And also on the other multimeters, you can see the result is very near from the Victor calibrator. And all this will indicate that those multimeters are very accurate for the price. There is no doubt about this. Okay, let's make a comparison with this milliamp power supply and see how they react between them. They are all connected in series to show the milliamps on the display, and we can see the difference between each of them, if there is a different offset, if there is a main difference. And we can showing this here for 4 milliamp coming from this device, which is very accurate. This device is very expensive. This is a professional device working on serious seats and area. It's a loop calibrator, as it's written on the board like this, and it's a very expensive device. It's a very accurate device, and it's used. This device is used to give a very accurate signal according the signal and the process you want on the loop. And this is a loop because all these multimeters are on milliamp section and reading the same value. Of course, this one, sorry, of course, this one has a different caliber for the 4 milliamp section, so we have to crank it up on the good caliber to have the nice value, and after this we need to change again the caliber. So for 4 milliamp you can see the different value on this one, and you can see it's negative because I make a little mistake, but I'm going to correct it. Okay, the milliamps are now on positive on the display of this multimeter, and you can see a very near result from each other, and it's for the price. I think those 3 microamp of offset on each one are very negligible at my sense for the accuracy. And you can see on this one there is a positive offset, and this one has a negative offset, but very close to those one. This one is definitely not a very perfect multimeter for DC current because there is a very important offset. So we are going to make a different value, which is 8 milliamp. For the 8 milliamp, you can see here this those multimeters gives a very close result, whereas this one has also an offset, an important offset. I don't know if this offset can be very significant, but at my sense, for a bench multimeter like this, is not acceptable to have so much difference between another brand. And this one needs to be okay on the good caliber as it is now, and you can see a perfect 8 milliamp written on the display. So according the display you can find here, you can see those multimeters give a very nice result. It's very impressive actually to give a very nice result like this. Mostly if you can see some bench multimeters like this, which is significantly with an important offset like this. So we are going to look further and see here for 12 milliamp, which is the 50% in loop calibration. Here you can see a little offset, positive offset, and here you will have the result very close to this milliamp generator. And you can see here also a little positive offset, which is not very significant, but on this one, which is brand new and very expensive according compared to those multimeters, you will have a important offset. This device costs about $150, this device. And this device is not able to give more accuracy than those one which costs just $20 and $23. It's very impressive. So let's go further and see the 16 milliamp, which you can see here on the display, very accurate, very near to this first value. And so you can see here a very important offset, and here a very slight offset. So the matrix, despite his age, is very accurate actually. So here we are going to choose step-by-step function, and you can see the current is rising step by step until we reach the 19,000 points on those multimeters, and you will see the maximum reading before toggling on a higher value. And you can see here we are approaching the okay, you can see now you lose one digit, and you will have now 20 milliamp. It's very accurate actually. You will have also here a little positive offset, and here a very important offset. For some application you have not to care about the one digit which is here, but for metrology and for other stuff which requires a very high accuracy, definitely this device is not perfect. But this one and this one are very nice and very accurate. It's very impressive. So if we want to see the toggling to the down, you can switch on here and see little by little where the hysteresis is, and you can see you need to go close to 18 for seeing the multimeter toggling to an 18 to 19,000 points. So this is a 19,000 points, but you need to rise the 18 milliamp for toggling. So if I go up, you can see we are always on 19,999 points on these multimeters on each one, which are very impressive actually. You can see up for the milliamp readings, you can see here your 1999 up. Okay, this is how you can see how it reacts with the toggling about the digit. Okay, 20 milliamp on each, you can see the difference. We are going to look with this resistor, which costs very expensive because its accuracy. We have 250 ohm, and this resistor is 0.1 98% of precision. It's a very accurate resistor, and we are going to see with this resistor on each multimeter what it can give in terms of results, and see the difference between each device. So here you can see on the RM219 true RMS, you can see the reading of this very accurate resistor, which is nearly from the value of this resistor. There is a little offset of 0.1 ohm, and it's 250 ohm.1. So on this multimeter, the RICHMETERS RM303, you can see exactly the good value of this resistor, which is very impressive, and it's give a very nice accuracy for the price and the budget. If you are interested by a very nice multimeter for a very low budget, I guess this is the best multimeter you can have, and the accuracy is very nice. Actually, it's very impressive. So let's see this resistor on the other multimeters. So you can see on this bench multimeter then the value is very accurate also. This is the result we expect from a bench multimeter like this. And even if those ones are not bench multimeters, they are able to provide a very nice accuracy, which is absolutely not a scam for the price. So let's see on this multimeter, on the matrix multimeter, how much it gives for the same value of resistor. You can see it's reading, and you can find a little offset, because here we can understand that this device is a little bit aged, and so you will have a little offset about the ohm readings, which is unstable at my sense. So the matrix give, in this case, a lower accuracy than those multimeters, and they cost a very lower price actually. So for other readings, I have here this little board which I use since a long time now, and it's helped me to read some capacitors and some resistors very easily, and also I use it to make some diode readings. And first, let's test some resistor, very high precision resistor, which are here, and see the reaction of these multimeters. Here we are reading a 100 ohm resistor, and the reading is very nice. Here 1 kilo ohm resistor, and you can see the reading is very nice also. And here for 10 kilo ohm resistor. So now let's make a measurement about from with the capacitors. So we are here with the capacitors, and make 1000 microfarad readings. It requires some time, but okay, we have 1070 microfarads. It's 1 millifarad actually. So let's see another one, which is 1 microfarad. This is the accuracy for 1 microfarad, and this one is about 10 microfarad. This is how it works with the capacitance. So now let's see the diode working. So I need to put the ground on this side and see the first silicon diode, about 1.6 volts, 2 diodes, 1.2, and see a red LED. You can see actually the red LED is glowing. Okay, this is the red LED, and it's perfect because lots of multimeters are not able to display so higher voltage for diode readings. Here we are for the red LED, which is actually glowing also, but it's not easy to see. Okay, it's raising, and okay, and see here for white LED, which is perfectly glowing actually. This is the white LED, and that means then this diode readings is able to read higher voltage, and it's very nice. It's very nice because even Fluke are not able to make some readings like this. For the instance, if I use this Fluke multimeter and do the same test, this Fluke multimeter, which is a little bit dirty because I make some mechanics with it, sorry for that. If you make some readings about diode, it's not able to read a white LED. You can see it's able to read a green LED, but not a white LED. So this one is a Fluke and cost very expensive. This one is not a Fluke, it's very affordable. So let's make the same test with this one. And so let's measure some resistor as we do earlier, and see 100 ohm. Look how it reacts. A very nice value for 1 kilo ohm resistor. Very nice value for 10 kilo ohm resistor. Very nice value. So let's make capacitor measurement. So for 1000 microfarad, 1000 microfarad, here it is, very nice. And for 1 microfarad, here it is, the same as the RM219. This is 10 nanofarad, exactly, nearly the same. So let's make some diode measurement. This is the diode measurement. So here we have one silicon diode. Here we have two silicon diodes. Here we have a red LED. Here we have a green LED, and here we have a white LED. So if we want, we can make some quick milliamp readings, and you can see here very quick milliamp readings, and this is the purpose of this little board. You can have here very changeable colors LED, which can give you changeable current according to the color it's display. So you can see here. Okay, the reading of the milliamp are very quick, and it's very nice to have a very quick display about the reading. And it reacts exactly the same on this one, which I'm going to show you. The reading is very quick, very fast, which is very perfect when you are making some troubleshooting. Actually, you need to have a very quick measurement. So, of course, The ohm readings are not so fast as a bench multimeters, but for me it's make the job, and it passes the test of resistor readings. So before I forget, I'm going to make some beep tests, and you can see the test. Very quick response. It can give you a short if there is a short, or if you are looking for a diode, but in diode that it don't emit a beep. So this is just for checking continuity tests, but it don't emit a beep when it's on diode. And it's exactly the same as this one, which is able to give a quick response. Okay. Okay, it's able to give a quick response, and it's worked very nice for this use. Okay, here we want to make quick reading test and see how much time it requires to make the resistor display on the screen. So let's see how much time it uses to give a 1 kilo ohm readings. Top 100 ohms. Okay, now for 1 kilo ohm, top 1 kilo ohm. Okay, now for 10 kilo ohms, top. Okay, it's not very fast. It's not quick as an bench multimeters, but at my sense, it makes the job actually. So let's do the same with the RM303 and see how much time it needs to read some resistor value. So for 100 ohms, sorry, I forget to tell the top. Okay, for 100. Now for 1 kilo ohm, top. For 100, for 1000 kilo ohm, sorry. For 1000 ohm, sorry, 1 kilo ohm. And now see for 10 kilo ohm, top. Okay, 10 kilo ohm. And okay, it's for some people who think that this multimeter is not very quick. I usually work with the multimeters, I brand multimeters. Okay, some brands are more quick than this one, but honestly for the price it makes a perfect job at my sense. So okay, if we want volt reading, the accuracy, the speed of volt reading, you can see top. It's quick, I think. I'm going to make a new test. Top. Okay. See on the other one for the voltage quick test. Top. Sorry. And see the voltage fast reading. Top. Very quick. Not exactly the same value, but very quick. Sorry. Top. Very quick. More quick than the other, I think. Very quick. This one is more quick than the 303, I think. Top. Okay, maybe the same. Okay, very fast voltage readings. In terms of energy, those multimeters requires exactly the same cells and they are AA battery. They are the same size, and if you are compared to this one, which was used, it was using AAA battery, and the duty of those battery are very short actually. But with those one, you can be sure to have a very nice energy during a long time for troubleshooting and make some tests, because those battery on a multimeter have a serious duty, and it's very nice. I love this kind of battery because they are very easy to find, not very expensive, and it gives a very nice duty on those multimeters. So, okay, this is the battery you need for those multimeters, and it's actually a very good point. Very easy to find, very easy to change, and not expensive. Okay, in terms of building, this multimeter is made like a different way because it's a very strong, it's heavy multimeter. If you can hear the sound and you can hear the click, it sounds very nice quality. And for this one also, it's not so heavy as like this one, but it's definitely more heavy, more, the build is very nice, as you can hear. And the perfect thing for this multimeter is that you don't have misleading reading, because when you are pushing your button between two caliber, sometimes you have an artifact of readings or measurement because the contacts are not exactly on the good position between two caliber, between them. So you will not find some problems and some weird results, because your rotary button will not slip between contacts and other like this. And you can meet sometimes this problem on the last version of this multimeter, which was the first multimeters made by this kind of builder, because actually they are not the same brand, but the chassis exactly the same. That means that the builder, the manufacturer of this multimeter is the same as this one, and they sold a lot of products, and the sellers put a new label on the screen, and it makes like he's the builder, but actually they are made by the same engineers, which comes from the same house actually. So the artifact you can find here, the glitch, you can meet some glitch between two caliber here, between this one and this one, or this one and this one, and sometimes you can find a very bad result according the ohm readings, mainly the ohms readings. But on this one, this default was corrected actually, and you will not have a glitch when you're switching from a caliber to another. So in terms of quality, you can see the sound. It's quite heavy actually. It's very impressive. We feel like we have a fluke in your hand, and the ergonomic version of this multimeter is absolutely amazing. So the main difference for me in terms of ergonomic is that the display of this one is more readable, because this one has a very thick plastic for protecting the display, as this one, where this one he is just under the plastic, and it can give you a more comfortable readings according if you have not a very lighting place. So actually I talk about this multimeter about to some people who are beginning in terms of working on different area, and of course sometimes it's difficult to have some devices, and of course to have a fluke. Some enterprises are not able to provide a fluke devices to the worker. So sometimes you need to have your own multimeter. So this is not a good, this is not an advice I'm giving, but of course you sometimes need a fluke which is a non-conditioned brand, unconditional brand, I mean, and of course according to the Cat 3 or Cat 2 you are more secure by working with this kind of fluke. But what I'm going to do here is a test with high voltage and see if those multimeters are able to pass the test. Of course, what you need to know is I'm not going to destroy those multimeters because of course for a full test you can see the channel of Joe Smith, who is able to make some very serious tests about on different multimeters, and also he's making some tests on China's brand like Aneng, etc., and see how this product can react in terms of a very high surge of current going through the leads. But I'm not going to make some test because this is not the purpose of my channel, and what I'm going to do here is just a test with a very high voltage and see if there is any current able to go through the package of these multimeters and measure the current coming from the grounding, the shell grounding, and the probe of these multimeters, which is able to simulate the fact that you are holding your multimeter in your hand. So if you have a very high voltage coming on the lead, and the purpose is to understand and to see if the very high voltage is able to go through the housing of the multimeters and circulate on your hand by the ground. Okay. So this is the test I'm going to do and see if they can make the job according, of course, if you can see here the 600 volt Cat 3 and the 1000 volt Cat 2, those kind of information, according if the manufacturer is very serious, which I don't want to talk about because I don't really know exactly what it's about, and so my purpose is to make a little test with high voltage and see how these multimeters will react in case where you have a probe connected to the very high voltage. Very high voltage means that you have more than 999 volts. From 1000 volts you are in the high voltage domain. Under 1000 volts you are in the low voltage domain. Okay, this is the law according the security of voltage in Europe. I don't know exactly what is about this in other countries, but this is on Europe convention. For the RM303, it's pretty dismounted actually. You can see very classical fuse, which are very nice and very easy to change. You will have here the shunt according the 10 amps readings, because this one is able to read 10 amps, and of course those fuse are which are a little bit flimsy actually, but this is what we can expect for the price. This one is the 10 amp fuse, and this one is the 200 milliamp fuse, and this one is protected, is made for the protection of the milliamp, the microamp section, and this one, the 10 amp, is made to protect the 10 amp section. So the internals are very similar to the first model, which is here. According those kind of chip, you can find a lot of multimeters like Fluke, which use the same technology. It was a time where those kind of chip was known like a very cheap and very bad component on a multimeter. But now this kind of chip, you can find this kind of chip, molten chip. You can find this technology of molten chip on the PCB, directly on the PCB, even on a Fluke market. So this is not a proof of cheapness, but this is just a proof of modernization of some product, and it's easy to make. It's help to give a very nice price for a lot of product actually. So with in the first Aneng, we have very little fuse, very hard to find, and this is on this one you can find a very simple fuse, which are very easy to find in case you need to change it. So I don't have to tell about this shunt, which is the shunt need for the 10 amp readings, because I think when you are make some 10 amps reading, you don't need so much accuracy, but actually the accuracy came from the fact that this shunt can be nicely made or not. I'm not to talk about, I don't want to talk a lot of this one because I'm not very interested on 10 amps accuracy. Okay, this is the internal, the quick internal of the RM303. For this one, you can see it's nicely rubberized, and it gives a very nice protection to this meter, and of course it makes it more heavier. Actually, this is a very beautiful multimeter, I guess. Look like very solid, very impressive. I like very much this one, and this one. The main difference with this one is that this one has the millivolt and the temperature readings. The conversion on millivolt to temperature. So let's move to this one. So okay, this is the RM219 true RMS dismounted, and you can see on the back, you can see firstly the shunt, which is exactly the same, but the tracks coming from the 10 amp fuse is added with a tin, and to reinforce, to enhance the track, because this one is given to read 20 amps, which is the 2 times more than the other multimeters. And you can see the architecture is exactly the same process molded chip, and also the same integrated circuit. You can see here this is an EEPROM, and this EEPROM is present on many multimeters of this brand. And so you have here a little PTC, but I didn't really care about this kind of protection because I'm not interested by this one. Just the things I want to notice here is that the fuse are bigger on comparing to this one. Those fuse are bigger, and it can give a more protection in case you will have a high surge of current. So the other fact is that actually the connection from this outlet to the PCB seems to be very flimsy. Actually, those kind of connections seems to be very, very flimsy, and I guess after a while of connection, deconnection, the probe you can break something, and this part here need to be enhanced actually, because I guess it will not last a very long time because it seems very flimsy, and you know that the use of these leads are very strong, very harsh, very hard, and it can make some vibration and chair stress on this part here and make some damage after a while of using this kind of multimeters. This is not very important actually, because those kind of damage can be repaired very easily, but if you are using this multimeter in emergency, and it's a good way if the damage will not occur when you need it in emergency. So to make this kind of multimeters perfect, I think the good way will be to make an enhancement of this area to prevent some damage from the push-pull leads and probe on this outlet. So this is a very simple made, very nice made. I think we don't need more to have more accuracy, because this multimeter is perfect, I think, for the price. And of course, we always need to not to forget the price. And actually, despite the price, and even if we found some flimsy component on it, this device is absolutely amazing for the accuracy and for the ergonomic way it provides for a very low budget. So I must admit that I love to use this kind of multimeter, because in case of height damage of this one, it's very easy to replace and not expensive. This is not the same case if you use a fluke, and fluke are expensive. And okay, you can guess that I use sometimes my own multimeters, my own equipment to work with. And sometimes it can be very helpful to use this kind of stuff, because they are not expensive, and if you lose them, if someone is able to steal them from you, you are not winnings. Actually, this is it's easy to replace. Just make an order from China and you will have a new one for not a very expensive price. It helps you to make the job perfectly, like it was a fluke or other brand. Some clients are able to want from you to use a fluke, because some multimeters have a following quality follower, and sometimes you cannot use unknown or unbranded product like this. According to the client you work with, you can work with this kind of device or you cannot. Of course, for me, because I make a lot of personal measurement according to my troubleshooting on Miscellaneous sites. So I don't always need a fluke. Of course, if I have to deal with a client, with a serious client, I'm not working with this kind of device. This kind of device is just helping me to work safety according to my tools. And if I don't need a fluke, I don't use a fluke to make some measurement. Okay, so this is the RM219 two RMS devices. Okay, here for the height voltage insulation test, we are going to use here a height voltage generator, which works in alternative voltage, and we are going to read the going through current with this microamp alternative current meter, which is a simple multimeter, but with a 200 microamp caliber, and it able to read some current going through the plastic. and other wires actually. So what we are going to do here is to test the insulation of the plastic of this device according the voltage which can go through the connectors and through the plastic. So for this I'm going to use paper foil like this. And make some stuff like this. Okay. And of course, this ground made by the paper foil is corresponding to your hand around the multimeters. So for this we need to put the probe together and connect the height voltage on the probe and the other lead on the ground of the multimeters. So let's see the test and let's read what the multimeter can display. So I'm going to pick up the microphone, you can see here, and I'm going to see how this height voltage works with this insulation test. To explain what I'm doing here, the height voltage is coming from this transformer. You must understand that this voltage is very high, is an order of 4,000 volts, alternative 4,000 volts, and this multimeter is able to see the current going through the surrounding plastic surrounding and the wires, the copper inside the apparatus going through the plastic. This is an electrostatic current, and let's see how it reacts with 3,000 volts. You can see the sound, the hiss coming from the sound. It emits some noise, and you can see the 40 microamps. And here we are from 3 to 4,000 volts. You can see more noise coming from the apparatus between the leads and the internal going through the component over through the plastic, and here we are about 70-80 milliamps microamp, and we need to know that we are about 4,000 volts, and this is how it reacts for 4,000 volts. Let's see now if there is any damage, any heat. I really don't know. This is the first time I make a harsh test like this. Okay, there is no trace, no hint about overheating, and the device seems to work very nice, I guess. Okay, it's work very nice. Okay. The test was with 4,000 alternative volts. 4,000 alternative volts. And it's about 80 microamps through the bonnet, through the capot, through the plastic surrounding. If you have 4,000 volts on the leads, you can have 70 microamps through your hands. If you are about 4,000 alternative voltage. Let's see the same test with the. Let's do the same test with this one. Of course, each device is tested with their own proper cords. Okay, let's see now in real time. I didn't make this test before. This is the first time I made this test with so much voltage. This is 3 and 4,000 alternative voltage, AC voltage, 4,000. So let's switch on the power supply, and you can see 50 microamps about the current going through the surrounding of the multimeters, through the leads, and to the grounding, to the surrounding of the multimeters. Let's go now. I don't know if you can see the sound. You can see a hiss coming from the device and very high voltage. This is something like 3,000 volts, and let's see now for 4,000. We are here about 4,000 volts, and you can see there is a little higher current, about 100 microamps through the surrounding and through the leads. So okay, you can see the sound coming from the device. This is an electrostatic current going through the leads over the surrounding of the multimeters. Okay. Here it's very dangerous. You absolutely don't want to touch because the voltage is very high. There is no very low high current, but the voltage can be very dangerous. So you can see something like 100 microamps. The leak current, electrostatic current, is about this value. And you don't forget, this is 4,000 alternative voltage for this test. 4,000 volts. 4,000. So the test is done. There is no hint of heat. Let's disconnect this power supply, which is very dangerous actually. Okay. Okay. There is no sign of heat, no sign of okay, let's switch on and see if it's always working. This is the first time I make the test, and Okay, it works fine. Okay, it works fine. Okay, the test was about 4,000 volts. Okay, each test was made by their own cable, of course. So this is my review of those multimeters, which I found very exceptional for the price. And the tests we see just now was about 4,000 alternative AC voltage, 4,000. Okay, this is all for today. I think this is a long video. I hope you like it. It was Alexander again, and see you soon.